Hello and welcome to Windows Azure Developer's Introduction. This is part of Intertech's Oxygen Blast series and was recorded in September of 2010. My name is Jim White and I'm an instructor and director of training at Intertech in Eagan, Minnesota. I'll be taking you through today a look at the Microsoft product known as Windows Azure, an introduction to some of the development tools and technology available to you. You'll find this presentation today in electronic form located out on the internet at intertech.com/blog. What are we going to be looking at in this presentation today? Well, we're obviously going to introduce you to Windows Azure, exactly what is the product. Take a look at why you might want to move your applications and data to Windows Azure. Explore some of the tools and technology you're going to need to work in the cloud environment. Look at the Windows Azure architecture, the pieces not only on your laptop or desktop to do development, but also what actually exists in the cloud to run these applications and data stores. We'll take a look at how you build simple applications to include something known as web and worker roles, and how you put data into the cloud, including how you put things in Azure Storage and SQL Azure. And then we'll wrap up with an explanation of the cost of Windows Azure, so you can start to do some compare and contrast about applications in your own data center versus how they might be paid for in the cloud. As I mentioned again, information you see today is available at www.intertech.com/blog. If you really do need some of the demo code, and the demo code that we're going to be looking at today is actually very simple, a little hello world application, but if you would like that code, please feel free to email me. Again, my email is jwhite@intertech.com, and you'll find that email address will be printed towards the end of the slide presentation today as well. So yes, we are going to start by looking at a little Hello World application in Windows Azure. But as part of this Hello World application, a couple of things that I'd like to do beyond just taking a look at a small and simple application is compare and contrast the application you're going to see today in Windows Azure with what I'll call a normal ASP.NET web application. Many of you probably worked in the web environment before and had to build a simple ASP.NET application, or maybe even a complex ASP.NET application. We're going to see that the origins of what we might see in an ASP.NET application are also going to be found in something known as a web application inside of Azure. We'll also take a look at some of the SDK, the Windows Azure Sdk, which is going to be required to build applications from your laptop or your desktop. And we'll also look at how we deploy applications to the actual Microsoft data centers through something known as the Windows Azure Developer Portal. Each of these topics we'll take a look at in more detail later on in our presentation. So first off, why would we maybe want to move into the Windows Azure cloud? Well, it's always available. Microsoft is running the data centers, and because of that, it's always up. And it's always easy to get into. In other words, as we'll learn here through a little bit of a demo in a second, prototyping, rapid development, all are easily done through the Windows Azure cloud. Having worked in several companies, for example, one of my last companies was Target Corporation, it could sometimes take several months to get all the equipment necessary to start up a new project. With Windows Azure, it's always available and ready to go. If you're willing to pay the price, a new environment is at your disposal in a minute's notice. Money is also an often cited reason for moving things to the cloud, in particular the Microsoft Windows Azure cloud. Cheaper implementation, you don't have to buy all the hardware, don't have to buy all the software, so it usually saves us money with regard to finding applications in the cloud versus finding them in our own data centers. And it's also typically faster market, again going to that whole idea that it's easier to get set up and running. And we also find, and this is something the accountants in our organizations really like, that it's an operational expense versus a capital expenditure. Building data centers are expensive, and the second you get one built, the chances are you might start to blow out the walls of that very expensive data center. When we look at the cloud, you're paying for only what you need. And if you need more, you pay a little bit more. If you need less, you pay a little bit less. And it's an ongoing cost versus a capital expenditure, which is a depreciating asset that's usually not going to last us over the long haul. Scalability is also another reason why many organizations are looking at Azure. As I just mentioned, you might have increasing needs and therefore either have to find more data centers or some way to get more capability into your data center. Not an easy proposition given four walls and the physical facilities of our computing environments. Azure allows us to scale up as needed. For all practical purposes, we have an infinite supply of computing environment that Microsoft provides us in the data centers they've got located across the world. But just as importantly, we have to also think about scaling down. Maybe you have a need that's driven by, say, Christmas time traffic, and after Christmas time that traffic's going to go way down. In order to run things in today's traditional model, your data center would have to be outfitted to meet that Christmas time rush, and then the rest of the year it sits mainly idle. Well, given Windows Azure, we can scale down as we need to, as much scale up. So it's on both the positive and the negative scalability that really is addressed by Windows Azure. And it's all under a pay-as-you-go model. You don't have to pay for excess capacity, and you don't have to pay any more than what you would have to on a general basis for that larger scale ability. In other words, you're paying the same price. You're using and paying for exactly what it is you use. Manageability, not sure about you, but with regard to all the operating systems and upgrades to those operating systems and all the software and the upgrades to the software and the networks and the hardware and the upgrades to those, typically running things like our data centers becomes a full-time activity for several people. And what we're using when we start to look at the cloud and Microsoft Windows Azure is allowing those folks, Microsoft, to really wrestle with and manage those details, letting us focus in on those things we do best, which is writing software for our clients and for our needs. Let the people who really do much better at dealing with hardware and upgrades and things of that nature manage all that activity. It is a familiar environment, as we'll learn through our demo here in just a bit. .NET, SQL Server, Windows, all technology which we know. And yes, while there are many other clouds out there, in other words, cloud environments, Amazon and Google and many others have cloud environments today, we're going to find the Windows Azure environment allows us to leverage a pretty large investment in the technologies we already know, allowing us to migrate and get existing applications and data into the cloud easier. And lastly, we have geographical disbursement capability provided by the cloud is one of the reasons you might want to think about moving to the cloud. The world is getting a smaller and smaller place, and applications and data typically have to be closer to our customers, either for geopolitical needs or simply to make them faster. No matter how much we might like to think our applications are very, very performant, the speed of light is still a constraint. And if your application is located here in the US and your clients are in China, there are some constraints there that you may want to consider about moving applications and data closer to those clients. And of course also the availability of systems across multiple data centers, which is offered by the Windows Azure environment, allows us to possibly maintain an even better uptime over the long haul. So these are some of the often cited reasons for moving to the Microsoft Windows Azure cloud. We'll get into the details of some of these as we start to explore the technology in a bit. What I'd like to do now, however, is give you a little bit of a demonstration of that capability, again, through Hello World. Okay, as you can now see, I've started Visual Studio version 2010. And oh, by the way, I started Visual Studio as administrator. We'll learn a little bit more about something known as Development Fabric and Development Storage coming up here in just a bit. But in order for Visual Studio to kick off those two processes, it needs to be in administrator mode. So let's begin the creation of our Hello World application. As with almost all .NET development, I'll start by clicking on File, New, Project. And when the new project window comes up, you'll notice there's a new cloud template inside of the offerings. This is something that's made available as part of something known as the Windows Azure Toolkit, which is now part of my Visual Studio 2010. We'll talk more about that coming up as well. So I want to create a new, what's known as Cloud Service Project. So let me give that Cloud Service Project a name. Of course, we'll call it Hello World. And with that, Visual Studio now wants to know what types of roles would I like to add to the cloud service solution. There are several different types of web roles available, along with something known as a worker role. We'll talk more about roles coming up as well. But for now, I'm just going to add a simple ASP.NET web role. And I'm going to change the default name from Web Role 1 to Hello World Web Role. With that, I'll have Visual Studio create my solution. And if we take a look now in the Solution Explorer, I have a set of projects, actually two projects. One is called the Hello World project. This is the Cloud Service project. The Cloud Service project serves as kind of a wrapper for all of my role projects, and it also provides configuration for those roles. And I also have my Hello World Web Role. And a Hello World Web Role is really nothing more than an ASP.NET web application, but configured and outfitted to run in the cloud. And in particular, for those of you who are ASP.NET developers, you'll probably notice some similarity. First off, take note of the fact there's a default ASPX page, complete with code behind. There's also a web config file. The only real differences between an ASP.NET web application and our web role is there's a web role.cs file. We'll talk more about that file coming up in a bit, as well as several references to Windows Azure namespaces. So we've got Windows Azure Diagnostics, Service Runtime, and Storage Client. Again, more on those coming up in a while. So to begin the construction of our little Hello World application, let me go ahead and make a few small changes to the default ASPX page. Nothing big here. What we're going to do is add, first of all, a label on the screen that indicates to people we'd like them to enter their name. We'll provide a text box. And that text box, which we'll call name text box, allows them to enter some characters for their name. By the way, let's change that label here, that label 1 to label, or I should say name label. I'll add a break. And then let's go ahead and add a submit button so people can provide us their name. And lastly, we'll provide one more label on the screen, which will provide a message to our users about their name. So we've got a message label there, and we'll take out the initial text. Okay, so nothing very complex, and we'll show everybody now our particular ASPX page that allows people to enter the name, hit the button, and eventually get a message back. Now let me double click on the button to get us to the code behind, and in the code behind for button 1 click, we'll set the message label text to hello plus whatever's in the name text. I should say name text box text. Okay, so hopefully nothing there too complex for anybody to follow. A simple little default ASPX page with some reaction to a button click that displays people's names. So let's go ahead and save all these files and now test our application. Now remember, I've built a Windows Azure Cloud Service application. So as I just pushed F5 to begin testing this application, since we don't have a cloud environment on our desktops, what's really happening behind the scenes is Visual Studio has actually started now something known as the Development Fabric. The Development Fabric is a simulation of the actual Azure cloud environment. We'll talk more about that simulation coming up in just a bit. It has now launched the browser, kind of a Cassini type of environment here. It's launched the browser that's actually now pointing me to that simulated Dev Fabric environment. Allows me to enter my name, and there we see, once we click the button, my Hello Jumbo message. Alright, so nothing too fancy. One thing I'm going to take you to, though, however, is in my icon tray. We'll find an icon there now for Development Fabric. You'll see that it started, along with Development Storage is started. If I right-click on the Development Fabric and ask to see the user interface, I'll see that in the development fabric, Hello World, my cloud service project, is running, and in particular the Hello World web role is running, and there's one instance of that web role running. And I also can actually take a look at the trace log for that web role as well. I'm not using any of the development storage at this point, but there's also a similar UI to see whether or not the development storage is up and running or not as well. More on both the dev fabric and dev storage and what they can help us with coming up in a bit. Okay, let me close that UI, and I'll also close the browser that is actually running my application at this point. That will actually stop the development fabric as well. So now we've seen that my application is working well and we're ready to deploy to the cloud. How do we do that? Well, we're going to come back over to our Solution Explorer, find our cloud service project, right click on that project, and ask to publish. That actually is going to accomplish two things here. Visual Studio at this point is actually now creating two files, and we'll talk about and see those files in a second, and also starting up a browser and taking me to the Windows Azure Developer Portal. It's through the Developer Portal that I can deploy my code out to the Microsoft data centers, out to the, if you will, the cloud, the Windows Azure cloud. So let me get signed into that portal. And we'll see, once signed in using my Windows Live ID, I'm taken to a page that lists my projects. Today you can only have essentially one project associated to your account. Clicking on My Projects, I then get a list of those services that I already have up and running, along with storage that I have up and running. We're going to ask to create a new service. And you can see when I create a new service, I can select one of two types. Either something known as hosted services, that's things like web roles and worker roles, code if you will, running in the cloud, or a storage account. And we'll talk more about storage accounts and having things like Azure Storage, tables, queues, and blobs a little bit later in the discussion. So for now, I want to create a new hosted service. I'm asked for a label, so I'll put in there my Hello World demo app, and I can also optionally provide a service description. Next, it's going to ask me to provide a unique URL for my hosted service. This is unique across all of Windows Azure. So let's try a Jim's Hello World app.cloudapp.net and see if that particular URL is available. And it is. So now that I've got a URL for my application, what's left is to select where I'd like to actually deploy this service. Now, Microsoft has about a dozen data centers located across the world. A few of those, or I should say a selection of those, are also running Windows Azure. So you have to pick where you'd like your application to be deployed. You can obviously say anywhere, and say anywhere in Europe or US, for example, but I'm going to be a little bit more specific. I'm going to put it closest to me, which is in North Central US. So I'm going to deploy to the North Central US data center that Microsoft provides. I'll hit the Create button, and that'll take me to this next page of our deployment process, which is to actually specify the running code and the actual configuration for our environment. Now you can see that when I'm going to deploy, I first must pick whether I want to deploy this into production or into a staging environment. Obviously, a staging environment meant for giving us a kind of a test of the application, although the URLs that we would have selected for our application would at this point all just be kind of contrived grids. Whereas production site will actually use the URL we set up. In my case, the Jim's Hello World demo app.cloudapp.net. So I'm going to deploy right to production since we've already kind of tested things and have everything up and working to our needs. Let's go ahead and now deploy to production. And the thing it's going to ask for me now is my actual code file and configuration file. When I asked to publish out of Visual Studio, what happened is it brought up this portal, but at the same time it also opened up a Windows Explorer and created two files in a publish folder. One, the hello world.cspkg. That stands for Cloud Service Package. essentially a fancy WinZip with all of my code in it. The next file produced was something called service configuration.cscfg, again standing for cloud service configuration. So the cloud service package and the cloud service configuration file essentially represent the code I need to deploy to and through the developer portal to the cloud. When I come back now to this user interface, as part of deployment, it's going to ask me to upload my package file, in this case hello world package, as well as my configuration settings. The configuration settings tells the cloud environment how I want that code to actually operate, and that's housed in this service configuration file. So allow me to go back to the developer portal, click the browse button. Let's go ahead and provide the code as being that hello, whoops, I've got the wrong project there. So let's get the right project, our hello world project here. There we go, our hello world package, and then also our service configuration for that hello world package. We also need to provide a service deployment name. Most people provide the version number as a means to give each deployment a name, so version 1.0. Okay, now let's deploy that. Now, deployment does take a few minutes. So I'll come back in just a second after this is deployed, and we'll take a look at what we need to do next in terms of getting our new Hello World service up and running in the cloud. Okay, so we're back, and I was away for about 2 minutes to give you an indication of how long it took for the code, my little Hello World application, to be deployed into Windows Azure. And by deployment, we don't mean that the application is actually up and running yet. It just means the code and the configuration file have been moved into the cloud and are now ready for deployment. We see on the screen now, back at our Windows Azure Developer Portal, we see the fact that the code has actually been deployed. Oh, by the way, a warning if you'll note that, hey, I'm now starting to be charged for that code, even though the code's not running. Code that you have available and ready to run is occupying space and therefore being charged accordingly. And you'll notice it even gives me a status of my application. It stopped. And you'll notice it also even tells me the website URL, which is not actually active at this point yet, is Jim's Hello World app.cloudapp.net. Again, remember that was the URL that I chose. So we're ready to actually start our application. Yes, you could do some additional configuration settings if you'd like at this point, but we're ready to go ahead and get our application up and running. So I'm going to press the Run button. Now this will actually take even more time. In fact, the deployment will average somewhere between 20 and 40 minutes, depending on the size and shape of your application. Typically, too, the portal will come back and give you some kind of indication about what the average time is, at least at this particular point in time, given everything else that's happening in the cloud. But the average usually runs somewhere between 20 and 40 minutes, depending on the size of your application. So again, I'll be back later, and we'll chat a little bit more about the deployment, test our application, and then get into the details of what is Windows Azure. Okay, and now we're back again. And as you can see, my application has been fully deployed and is now running in the cloud. You'll note that the state is listed as ready. It took about 30 minutes for it to go through its initialization, busy, and then ready working states. If I now click on this link provided, Jim's Hello World app.cloudapp.net, I'll actually see a page brought up with my Hello World application running. And I can, just as I did in my local environment, type in my name, hit the button, and see my message. Okay, so now we've seen a small little Hello World application running in the cloud, having been deployed through the Windows Azure Developer Portal. Let's get into some more of the details of this environment called Windows Azure. So we've taken a look a little bit through our Hello World demo at the use of Visual Studio as the prime tool for use in developing Windows Azure applications. Although it doesn't have to be, we'll see that there are other options available to us here in a bit. We saw a little bit also of the Azure portal being used to allow us to deploy our applications into the Microsoft data centers. We'll now want to talk about the other pieces and parts of this environment, as well as what's actually happening inside those data centers. So inside a Microsoft cloud, inside a Microsoft data center, they have about 12 data centers across the world again. Not all of them run Azure. A certain number run both Windows Azure applications as well as house our Azure data storage, which we'll talk about coming up in a bit. The exact number and location is not well advertised, and that's on purpose. Microsoft obviously doesn't want those to be targets for any kind of malicious behavior. We do know that there is one of the data centers located in Chicago. In fact, it's one of the more recent data centers, and in that data center they have about 360,000 servers running. Each data center has, at least of these modern data centers, have what are known as C blocks, essentially the containers you see running down the highway on semi-trailers, just filled with servers. And inside of those C blocks, each of these servers can essentially be managed as part of that whole C block. In other words, if a certain percentage of those servers go down, that whole block is taken out and a new block comes in and replaces it. On each of the servers we'll find about 1.5 to 1.7 gigahertz CPU with approximately 1.7 gigabytes of RAM. Now each server is also running a modified version of Hyper-V. That's Microsoft's hypervisor. What does hypervisor do for us? Well, it allows those machine resources, those 360,000 servers in the Chicago data center essentially, to be shared across multiple applications and or data concerns. So if you will, taking a look at my picture here on the screen, each server running Hyper-V allows that server to be split up into multiple what we call partitions. One of the partitions is the host partition, if you will, kind of managing the operations of that server. Other partitions are what we call guest partitions, and it's on the guest partitions that your application runs. More specifically, where instances of your roles, web roles or worker role runs. We'll talk more about those coming up in just a bit. So these virtual machines allow for many instances, or many, if you will, pieces of our application to run, but not necessarily all having their own server, physical server that being. So what we call all those servers, along with load balancers, switchers, routers, and all the other hardware that exists in the data centers, along with the software on all of those pieces of hardware, we call that collectively the Azure Fabric. So the Azure Fabric, if you will, is a collection of everything physical along with those virtual server environments running inside the data center. Something known as the Fabric controller is, if you will, the brains behind all of that hardware and software running out there. The Fabric controller controls all those servers, both the physical servers as well as the virtual servers, controls all the software on those servers. It also actually controls and manages our applications that get deployed to each of those virtualized environments. So again, the Fabric controller is in complete control of all hardware and software that runs as part of what we call, again, the Fabric. As we've already seen, if you want to develop an application to run inside of that environment, most of us are going to start by using Visual Studio. You have the two choices, either using Visual Studio 2010 or 2008. I guess I should also say you could also use the Web Developer Express version, Visual Studio. Whichever version you choose is certainly adequate, although you will find that if you use the 2008 versions, you're going to be required to do some upgrades, put some service packs on there. Additionally, what else do you need? Along with Visual Studio, you will need also the Windows Azure tools, what I call WAT for Microsoft Visual Studio. And what we'll find is, with the Visual Studio and Windows Azure tools, you're now outfitted with a number of capabilities. First of all, things like the templates allow you to create cloud service applications, along with the actual environment to debug and test applications inside of your development environment. Current version of WAT is at 1.2, and what we say is that the Windows Azure Toolkit actually includes something known as the Windows Azure Sdk, and that's really at the heart of what provides us the development environment for Azure. We'll talk about that here on the next slide. So the Azure SDK is what really provides the actual API, provides the development tools and simulation environments that allow us to run, in our case typically inside Visual Studio, but if you have just the SDK, you don't need to have Visual Studio. In other words, if you're a hardcore developer who likes to write applications via Notepad, you can write applications in the cloud for Windows Azure using the SDK and Notepad. In fact, the SDK is even available for environments such as Eclipse. So the SDK is really at the heart of building applications, and it's the Windows Azure toolkit that's built around the SDK to be used inside of Visual Studio, or I should say maybe more appropriately used with Visual Studio. So the SDK is independent of Visual Studio. Windows Azure Tools is what is dependent on Visual Studio. What types of environments support the Windows Azure development environment? Well, you're going to need to have either .NET 3.5 or .NET 4. You'll also need, or I should say what is also supported, is either a Windows 7, a Windows Server 2008, or Windows Vista environment. So these are the operating systems that are also, one of which is also needed in order to be able to build applications on your box. If you have an older version of an operating system, say for example you have Vista or Windows Server 2008, you might find certain service packs or upgrades that are also needed. When you go out and you download either the Windows Azure Toolkit or the SDK, you'll actually see a listing of some of those fixes and upgrades, and I have quick links to bring those into your environment to get your development laptop or desktop in order for Windows Azure development. What else do you need? Well, your development box is also going to have IIS 7. This is a hard and fast requirement. A lot of people have asked, can we use IIS 6? And the answer there is no. A lot of the environment for Windows Azure was built on IIS 7, and so it really can't, IIS 6 can't be used because it really can't simulate what you'd find out there running in the cloud. Additionally, you'll need SQL Server. Most people are going to find it easy and available to use SQL Server Express. However, you can use a full-blown version of SQL Server as well, but it has to be at that 2008 level. So either SQL Server Express 2008 or 2005, or a full-blown SQL Server 2008. Again, depending on which version of SQL Server you have, you might find, again, the need for hotfixes or patches or what have you. Again, see the download page, and the download page will give you details on what upgrades you're going to need to make. As part of the Windows Azure Toolkit, or more precisely as part of the Windows Azure SDK, you'll find the Dev Fabric and Dev Storage. So as you write applications in your .NET environment using something like Visual Studio, you're writing in an environment that, once ready to go, isn't running some sort of virtual server type of environment. In other words, your desktop, your laptop, is probably not outfitted with hypervisor and some sort of virtualized environment. So what to do if you're trying to test these applications that are destined for that environment? How do we test them effectively? Well, that's where the Development Fabric and Development Storage come in. These provide a local cloud simulation environment for testing. So Dev Fabric and Dev Storage are part of the SDK, which means, obviously, that means they're also part of the Windows Azure Toolkit. Now, the Dev Fabric uses a set of processes, a set of EXEs on your development machine to simulate the virtual machines. When you press F5 again in Visual Studio, that's when Visual Studio starts up the Dev Fabric. And the Dev Fabric is based on what we say is 90% of the real fabric. In other words, it's a simulation up to 90%, something that we'll talk a little bit more about coming up as we chat about some of the differences. So it's not an absolute perfect simulation, but about as good as we can get for our development environment. Also, and importantly, the Dev Fabric isn't going to check whether or not your code will actually run in the cloud. What do I mean by that? Your application running in your development environment may be using packages, might be communicating with things like processes that do not exist inside of the actual cloud environment. Inside of your development environment, that's fine, and it will actually work, and you'll find no issue. But when you move to the cloud, obviously those pieces not being available are going to create you issues. And unfortunately today the Dev Fabric doesn't do a check whether or not that code or whether or not those processes or whatever it is that you might be using are actually available or not. So it's incumbent upon you to make sure that what you're building to actually does exist in the cloud. You'll also find the Dev Fabric is a bit slower than what you'll actually find in the cloud. There are several reasons for that, again some of which we'll talk about coming up, but the Dev Fabric should give you some indication that if at least performance is okay under Dev Fabric, I'm not going to give you 100% assurances, but there's a pretty good chance that things actually improve when you move to the cloud as opposed to in your actual development environment. Lastly, Dev Storage, along with Dev Fabric, again provide the full simulation environment, but Dev Storage is simulated through none other than SQL Server. That's why the need for either SQL Server Express or SQL Server on your box. Azure Storage, as we'll learn, is made up of 3 types of storage: queues, tables, and something called blobs. We'll talk about those and the differences coming up. But that type of data is going to be stored, at least large chunks of that data are actually going to be stored in SQL Server tables that are set up by Dev Storage. We took a look at this in our Hello World application. That is, when you actually are running an application or debugging an application through Visual Studio, you can get at what's known as the Dev Fabric user interface through that little desktop item on your screens. Pulling up that Dev Fabric UI allows you to see what instances of your web roles and worker roles are running, and actually also see a little bit of the stack trace. We also talked about and saw through our Hello World demo that once you've got an application built and tested in the Dev Fabric, you want to publish that and deploy it to the cloud. The act of publishing is using Visual Studio or whatever tools you might have to create those 2 files, what's known as the service package file, a CSPKG file, which is a fancy WinZip of all your code, as well as the CSCFG file, the service configuration file. The service configuration file, which we'll get into more details of coming up here in just a while, gives the portal and the Fabric controller information about how you want your services running in the cloud. Once you've got those files, you provide those either through the developer portal, as we did through our Hello World demo, or there is actually also a command prompt service management API that you can use to deploy your application to the cloud. Deploy those 2 files, your code file, the CS package file, or the CS, I should say, and the CS config file to the actual Windows Azure cloud. Let's get into now some of the architecture of Windows Azure. Now that we know a little bit about the development environment and what tools we need, we've seen the actual developer portal and how to deploy and publish applications through that portal into the cloud. Let's talk a little bit about what the cloud is really made up of. The Windows Azure name is actually a name that is used quite a bit in this environment, and in some cases one might actually say used, maybe overused. Windows Azure refers to many things. You'll see typically something known as the Windows Azure Platform referenced by Microsoft. The Windows Azure Platform includes lots of things. It includes the development environments and the development simulation environments. It includes the actual cloud environment. And in particular, one of the things that the Windows Azure Platform includes is something called Windows Azure, again, name being reused here, which is really the core for our running components. Windows Azure is where our services actually run out of. You'll hear 3 different pieces of Windows Azure. In other words, Windows Azure consists of 3 different what we call services. Something called compute, which is where our code actually runs, things like our web and worker roles. Something called storage. Azure Storage provides a set of capabilities to persist data in 3 different forms, which we'll talk about, along with management capability, the ability to actually track and manage and get information from this environment about what's going on. So inside of Windows Azure Compute, Compute is where we have our roles running. We talked about how Windows Azure Compute really is where we have one or more hosted services. And there are 2 types of hosted services today. We have what are called web roles and worker roles. Web roles, as we learned through Hello World, is simply a web application. In fact, it's actually fronted by an instance of IIS. And then we have also worker roles. Worker roles, as we'll learn, serve as background processes. Think of them as Windows services or as batch processes, performing work, but really not having any kind of visual or user interface attached to them. Now, there's something called roles and role instances. We've talked about web roles and worker roles. Inside the Fabric controller, the Fabric controller is going to assign each row, each role, its own what we call guest partition. In other words, part or a slice of one of those virtual machines we talked about before. So each of the roles gets its own virtual machine. However, we have to be a little bit careful here with the terminology. When you deploy your application, you have things like the Hello World web role. But you might request what we call multiple instances of that role be created, asking the Fabric controller essentially to make copies, duplicates of those roles. And why do we do that? Well, to provide for that scalability. Maybe Hello World is going to get hit by millions of users today. A single instance of that application running in the cloud may not be sufficient to handle all of the million users. So we might ask for many instances, what we call role instances, to get launched. The Fabric controller actually will take care of that. In fact, give each role instance its own guest partition. In other words, get its own virtual machine. So when we talk about roles, if you will, that's the chunk of code that represents our applications. And again, we have two different types of roles, web roles and worker roles. Web roles is a web application. Worker roles is a background process. But with those roles, we might have several copies or several instances of those running to meet scalability needs. In fact, many applications are made up of roles, many types of roles, or I should say many instances and many types of roles. So you might find in many applications both web and worker roles are being used. Users, for example, would actually interact with a web role, for example here, to collect some information about orders. And then, through the use of something known as a Windows Azure Storage queue, provide messages back to something known as a worker role to actually process those requests or those orders, if you will. When we talk about role communication, roles can actually communicate directly with one another, or they can use, as shown in this example, messages through Azure Storage queues to communicate. And we'll talk about Azure Storage queues coming up in our talk here in a bit as well. So web roles typically are the front end, the user interface, while things like the batch processing of orders are done through a worker role. As we saw through the Hello World demo, when you create a new project, you're actually creating what's known as a cloud service project. So in Visual Studio, as we saw represented in the Solution Explorer, when we did our Hello World example, Hello World served as a cloud project. Inside of that, we have many role projects, in our case, a Hello World web role. Now the cloud project that we created essentially serves as a container for all of the roles we create. You might have several web roles, you might have several worker roles as part of any particular project, as we just mentioned, depending on what kinds of user interface you have to have, what kinds of back-end processes you might have. They're going to communicate together to get the jobs of your particular application needs accomplished. So you've got a container for all these different roles that you have. The cloud service project also is the house for configuration information. In fact, that configuration information is represented by two very important files. One of the files is something known as the service definition file. The service definition, CSDEF file, as we'll learn, is static, never changing. The other, the service configuration file, provides information that is a little bit more dynamic. So the service definition and the service configuration file, both of these files are again housed in the cloud service project. So not only is the cloud service project a container for roles, it's also a container for our configuration for all those roles. It's the service configuration information that the Fabric controller is actually used to learn how to deploy and operate our applications inside of that Fabric. Again, Fabric being all the servers and hardware and software that make up the Microsoft data center. Both these files, both the service definition and service configuration files, are XML files. So if you're a hardcore XML editor, you can actually do that by hand in Visual Studio. But there's also a graphical user interface that allows us to make changes to those so that it's not so much dealing with angle brackets as much as it is in making selections inside of this UI. So the service definition file, the first of those two files, is what defines the overall structure of your service. As I mentioned, this is going to remain static at runtime. And what does it provide? What information is provided in the service definition file? Well, first of all, the size of the virtual machine. Remember that guest partition is a slice of a physical box out there in the data center. Well, this file defines how big of a slice do we need. In my example here, I've shown that Hello World web role wants a large virtual machine. There are 4 different sizes: small, medium, large, and extra large. Essentially, when you ask for an extra large, you're asking for the entire box. You want your guest partition to be the entire box, the entire server out there. You can ask for any one of these sizes, but obviously the larger size you ask, the more you're going to have to pay for that particular service. Also defined inside of the service definition file are things like whether or not you're going to need access to the actual native code environment out there, whether you're going to execute code and outside our managed code of, say, C# or Visual Basic. Also lists what ports we're going to use, and defines what we call our configuration setting variables. Now, this is where we set up the configuration settings, but not where we actually provide values. And we'll talk about that when we see the next file here in just a bit. So the service configuration file is what allows us to define configuration values for those configuration settings we define in the definition. It also does things like allow us to set the number of instances we want running for our role. So in my example here, you'll see for Hello World web role, I want 3 instances. In other words, I want 3 copies of this particular role running inside of the data center that Microsoft provides. Remember, each role instance gets its own guest partition out there. In fact, they're going to be on different machines in order to provide for that high availability. And I also, again, as this example shows, set up my configuration settings. You might have saw in the last or previous slide, diagnostic connection string was the configuration setting in this particular example that I'm setting up, but no value is provided. Here the value is provided. What's defined as service definition is static. Doesn't change ever once deployed. Whereas the service configuration file defines for me those things which are more malleable, more flexible, that can change at runtime. So things like the size of the virtual machine can't ever change. That's defined in the service definition file once it's running in the cloud without tearing down the application and redeploying. Whereas the number of instances I have can be quickly changed. And so this is how we get that scalability that Microsoft Windows Azure provides. There are several different types of roles, as mentioned. There's the web role and worker role, and in particular, when we look at web roles, there are 4 different types, if you will, or subtypes of web roles, all based on the type of front-facing web application you like running. As we saw in our Hello World example, we've got the ASP.NET web role. Mimics just an ASP.NET web application. If you're of MVC type and you like MVC2, you can create an ASP.NET MVC2 web role. We also have the CGI web role, so if you want to work with fast CGI and write languages such as PHP or Python to run Azure, you'll build a CGI web role. And lastly, we have a WCF service. Not really so much of a user interface type of web role, but a headless service that is exposed through HTTP or HTTPS endpoints out there. So for those of you who do Windows communication type work and do WCF services, and you want to host those in IIS, this is the web role for you. So those are the 4 different types of web roles we have. Now again, a web role project looks pretty much identical to a non-Azure web role. In other words, if we were to look at an ASP.NET web role and compare that to an ASP.NET web application, we'd find they're nearly identical. Similarly, if we were to look at a WCF service application, we'd find that looks almost identical to a WCF service web role. So these web role projects look very, very similar to their non-Azure counterparts. In fact, again, the only difference is, as we saw in our Hello World example, is the fact that in the web role we'd see 3 additional Windows Azure references and that web role CS file that is also added. So taking a look, for example, at our Hello World example again, if we were to look at our Hello World web role, the only real differences here again are those 3 additional Windows Azure references and the web role CS file. Those are the only things you would find missing from a typical ASP.NET web application. Now, what's in the webrole.cs file? Well, it acts kind of like a global ASAX file in a traditional ASP.NET application, essentially serving to do initialization type work. So when Azure starts our web role and starts our code running inside the cloud, it calls on the onStart method of this webrole CS file. And in this onStart method, things like diagnostic monitoring services, connections maybe to databases, things of that nature might be started and initialized. Do whatever type of code you need inside of webrole to initialize your particular instances. Let's also take a look, while we're in the mode of looking at some code inside of a web role, let's look at just some Azure API. This could be used in both web roles or worker role. For example, from the service runtime namespace, we'll find a couple things that can be very, very useful. First off, what if your application needs to go back and forth, say run in the cloud in some cases, but also run in premise, in other words in your data center in other cases? How would you build your applications to do that? Well, very conveniently in the service runtime namespace is a role environment class that has an isAvailable property. And if true, this will tell you that you're actually running in the Azure cloud. By the way, if you're running in Dev Fabric, that simulation environment, this would also be true. And when you're not, obviously then you're running essentially in your data center or wherever that particular application is running outside the cloud. So this conditionalization allows you to write applications that in some cases might run in the cloud, in other cases may not. What else is available from the service runtime? There's an ability to get configuration settings value. Inside the cloud, you don't have access to things like the registry. In fact, even the file system is something you want to be very, very careful about using. So things like configuration values, environmental settings that you want to set up, you're going to do that through those configuration files that I mentioned, service definition and service configuration. How do you then get values from that configuration in your application? You call on the service runtime API, and in particular call on role environment get configuration setting value to get that value. What other types of API does Azure offer? Well, there's a diagnostic namespace. Now, if you're used to running things like ASP.NET applications in an IIS environment in your data center, you have access to all sorts of logs and events and traces and things of that nature in that environment. Typically, we'll remote desktop into those boxes and get all that data out. But in the cloud, you don't have direct access to those files. So how do you get information about what's going on in your application? How do you monitor the status and health of your application? Well, you're going to have to become familiar with the diagnostic services that Windows Azure provides and become familiar with the diagnostic namespace to be able to pull information in and out of these kinds of logs. So for example, here we can use the diagnostic namespace and a trace class to write a line in the Azure trace logs. Let's take and turn our attention now to worker roles, the other type of role project that we'd find in Azure. Worker roles provide background processing. Again, think headless type of applications. So think of a worker role as kind of a Windows service. You can use them for doing batch processing, queue processing, essentially non-HTTPF, WCF service hosting type stuff. Any plain old number crunching is what you want to think about for use when you think about worker roles. Again, unlike web roles, Windows Azure Toolkit for Visual Studio provides just one worker role template. So you don't have to pick from the types of worker roles you want. There's just one today. If we take a look at a worker role project, for those of you who do, say, WCF service type work that's not based in IIS, you probably see some similarities. What you'll find inside of a worker role project, again, the namespace references for the Windows Azure code, the API. In addition, you'll find a worker role CS file as opposed to a web role CS. Oh, by the way, for those of you again familiar with doing things like WCF work, you'll notice an app config file very similar to those types of projects. Inside the worker role CS file, this is the kickoff or entry point for a worker role. So the onStart method of a worker role project is just like the onStart method of a web role. Allows us to initialize that role and get anything started that we need to before the worker actually kicks off. But then additionally, the worker role CS file has a run method, and it's in the run method that a worker role actually performs its work. So in a run method, what we'll find typically is an infinite loop. That infinite loop is where we do our work for the worker role. And it's pretty typical to see it do some work, go to sleep for a while, wake back up, do some work, go to sleep for a while, in an infinite loop scenario. In fact, if you actually stop the infinite loop, Windows Azure and the Fabric controller will think that this worker role has actually fallen down and then start up a new instance of the worker role. So either you do the while loop infinitely, or the Fabric controller is going to be continually starting new instances of your worker role to essentially do the same thing. So what does it cost to run either a web or worker role instance inside the Azure cloud? Well, you can start off fairly inexpensively. That is, if you choose to use a small size virtual machine, remember there are 4 sizes, small, medium, large, and extra large. If you choose to use a small partition inside of guest partition inside of one of the machines in Windows Azure, that'll cost you 12 cents an hour. And you can see the available resources here you get with that in terms of CPUs and available memory and such. So you can also choose then to run in a much larger VM, essentially taking up either more or all of one of those actual servers out there, but that will actually cost you more. By the way, you're charged per hour, and partial compute instance hours are billed as full compute hours. In other words, if you started at 58 minutes after the hour, that's 1 hour, even though that hour ends at the top of the hour and you start a second hour. So recognize that this 12 cents an hour is based on a partial hour as well as full compute hours out there. Let's take a 5-minute break, and then we'll come back and we'll discuss storage to include both Azure Storage as well as SQL Azure inside the cloud. Well, welcome back to our Windows Azure Developer's Introduction. Let's take a look now at some of the storage options that are available in Windows Azure. In particular, we have something known as Azure Storage. As I've mentioned before, there are 3 different types of data storage in the cloud, something known as tables, blobs, and queues. Now, this is not a relational database. If you want a relational database in the cloud, you're going to use SQL Azure. We'll talk more about that coming up in just a bit. No matter which type of Azure storage you use, table, blobs, or queues, each of which we'll talk about here in a bit, they are all stored 3 times. In other words, each are replicated by the Fabric controller 3 times inside of the Azure cloud. So Azure Storage is scalable and typically cheaper than storing data in relational form in the cloud. We'll talk about cost coming up here in a bit as well. So when we talk about accessing Azure Storage, the 3 types of Azure Storage that we have available can each be accessed through REST over excuse me here for my pointer. Let me get my pointer set up. Each can be accessed through REST over HTTP. This gives us some advantages. For one thing, it means that applications both running inside the cloud as well as those running in your own data centers, or what we call on-premise, can access this Azure Storage the same way. So we don't have to have an application in the cloud to actually access Azure Storage. And in fact, it doesn't even need to be a .NET application. A Java application or some other form of computing code can access through REST over HTTP Azure Storage, tables, blobs, or queues. To access the storage inside of managed code, in other words from a .NET environment, the Azure SDK also provides something known as the Storage Client API. This is a .NET API that abstracts away a lot of those details of the REST API. So if you're writing .NET code, especially if you're writing .NET code that's destined for the cloud, it's pretty typical that you're going to use the Storage Client API. Now again, this is wrapping around the REST API, so it still uses REST API underneath the covers, but it helps abstract away a lot of those details from you as a .NET developer. So giving us a little bit of a pictorial again, on-premise being those applications you have running in your own data centers or in your own environments, versus off-premise, those that are in the Azure cloud, can access tables, queues, and blobs, again those three types that make up Azure Storage, via REST API directly, or if you're running in a .NET type environment or running managed code, you can do that through the Storage Client API. Again, the Storage Client API provided through the SDK. Let's talk about the first of those types of storage, and that is queue storage. Queue storage provides what we call reliable and durable message stores. If you will, think about queue storage as kind of an MSMQ or WebSphere MQ series in the cloud. The implementation is quite different than that, but you can kind of use that as an analogy to think of this type of storage. And queues allow services to communicate with one another in what we call loosely coupled fashion. We hinted to this earlier, and that is something like a web role, which is usually customer facing, a user interface, a web application, providing, for example, a means to enter an order, communicating with a worker role that processes that order via a queue. A web role will put a message into the queue, worker role is sitting there waiting for messages. The two roles don't know about each other, so they're loosely coupled. The only thing they know about is this queue and the messages in that queue. Here's some example code for, in this case, getting messages out of a queue. The very first thing we need to do in the Client Storage API is get something known as a Cloud Storage account. A Cloud Storage account essentially represents your portal, your access to Azure Storage. Again, either any of the three types, be it queue, blob, or table. So we get a Cloud Storage account object. With that account object, we then want to get what's known as a queue client. Queue client, as its name implies, provides us access to queue storage, a part of Azure Storage. With the queue client, we get reference to a particular queue. Each queue has a name. In this particular example, our queue's name is Hello Queue. Once we've got a queue, we'll ask to get message. And there's also an overloaded set of methods there. There's also a get messages to gather a collection of messages, but in this case we've just got a simple while loop, presumably a part of maybe some sort of worker role here since it's in a run method, going out and getting each message. And you'll notice we get a cloud queue message, and with that cloud queue message we extract its contents, do whatever work we need, and then lastly we need to delete the message. Now this might seem a little bit odd. Why would we get a message and then tell the queue to delete it? And it's actually built that way so that, say for example, something happens inside of our worker code here where an exception is thrown, or something happens where we didn't fully process that message. Well, the idea behind these queues is that once you've gotten the message, you have a certain lease on that message for a certain amount of time. 30 seconds is the default. If you don't complete your work within 30 seconds and then delete the message, well, the message is actually put back on the queue, so the next process coming along will actually process and take care of that message. So it provides for that durability kind of idea, making sure that all work is taken care of eventually. So that's using queues. How about table storage? Well, table storage offers what we call structured tables, similar to what we'd find in relational databases, but not the exact same thing. These are tables that don't have the same relationships that you'd find inside of a relational database. In other words, you can't relate two tables to one another directly like you do with foreign key relationships in some sort of SQL database. And also, indexes are a bit limited. There's no setting up of a custom index. Each table has the concept of an index, basically a primary key on it, but beyond that, setting up any kind of custom index is not there today. So you can kind of think of table storage, as I say, like a fancy spreadsheet. Yep, there's the concept of rows and columns which you could put data in, but you can't exactly relate two spreadsheets to one another. Also, don't view table storage necessarily as a replacement for some sort of relational database management system like SQL Server. In fact, the two can work cooperatively together to provide unique and different ways of storing information. Table storage is more of an alternative to RDBMS for certain application situations. as opposed to a replacement for some sort of relational database. So relational database is still a place in many of our applications, and that's not going to change with Azure Storage. So again, in table storage, we're going to find data stored in row column form, but the relationships between rows and columns are limited. So table storage keeps what we call entity data. That is, takes domain objects, data transfer objects, plain ordinary CLR objects, POCOs, however you want to label them, takes these types of objects, like I've got shown here in the form of customer, and takes those objects' properties and stores them in row column form, and again, what's kind of like a fancy spreadsheet. So taking customer IDs and first names and last names and storing those in a table row column form. So it's structured data, but not data that we can relate, for example, customers to orders or any data from this customer table to other tables, at least not without a fair amount of work on our part, no work that's going to be handled by table storage directly. Here's some example code for working with tables. Again, very first thing we need to do is get a cloud storage account object, that first line of code, but then beyond that, once we've got a cloud storage account object, we get a table client. Sound a little bit familiar? In the last example we saw a queue client. Yep, the very first thing you do is get a client object from your storage account based on the type of table storage, queue storage, whatever type of storage you're working with Azure Storage. So in this case, a table client object. From that table client object, we'll check to see if a particular table, in this case a customers table, exists. If not, go ahead and have it created. Next thing we'll do is create what's known as a context object, in this case a customer context object. For those of you who've worked with ADO.NET, that name might sound a little bit familiar. Essentially, it's very similar to, if not identical to, the concept of data service context, essentially a wrapper to provide all sorts of access to our data, in this case tables. With that customer context object, what will we do? We can use it to add objects, in this case a new customer object, or save changes to the table. So in this particular example, you'll see we've created a new customer object, a new POCO, and then used that POCO to actually save its properties into what's known as the customers table. And the save changes just, if you will, kind of commits all that data into the table. Blob Storage is the last of the three types of Azure Storage. Blob Storage houses large binary data. That's really an open-ended way of saying just about any type of information you can put in 1 and 0 format. Typical examples in Blob Storage include things like images and videos, documents, anything you want organized similar to what you'd find inside a file system. In fact, you can kind of think of Blob Storage as a replacement for a file system. You don't really have the file system in the same way you would think about file system in your applications that run on your desktop or inside of your own data center, because you are sharing a server and the applications that you have running that partition, and that application might get moved to a different partition by the Fabric controller at any 1 minute. So anything in the file system of that particular server and that particular partition may evaporate, as far as you're concerned, almost instantaneously. So how do we deal with information that we normally might find in a file system? Well, instead of using the file system, you use Blob Storage. Blob Storage is set up such that you can put any of these files, any of these pieces of information in 1 or 0 format into something known as a container. And essentially, a container serves as a file directory, if you will. So here's some example code of how we access Blob Storage using the Storage Client API. Again, we get our storage account object and then get a Blob Client object from the storage account, and then ask to reference a particular container. Again, if you will, access a particular folder or directory that we're going to put information in and out of. In this case, something called container name. We check to make sure that that container exists, if not created, and then we request a reference, a blob reference. In this case, to a simple text file name called myfile.txt. And lastly, we upload our text. In this case, this is a test type of text into that blob. Now, in this case, we're uploading simple text into a text blob, but we could just as easily upload things like music or video or other data through streaming and what have you into other blobs. Blobs, again, are just houses for 1 and 0's information. How much does Azure Storage cost? Well, the cost is 15 cents per gigabyte per month, or roughly translated thereof. However, in addition to the actual raw storage, there's other costs associated with Azure Storage. There is a transaction fee. For every 10,000 storage transactions you have in and out of Azure Storage, that's an additional penny. And you have transfer fees. Data transferred in costs 10 cents per gigabyte. Data transferred out costs 15 cents per gigabyte. By the way, take note too that in Asia those charges are higher. Microsoft has explained that charges in Asia are a little bit higher because the cost of setting up data centers in Asia is higher. So in addition to the raw cost of storing things, the 15 cents per gigabyte per month, you also have transaction charges and data transfer, both in and out charges. Now, what about some of the numbers around how much data you can put into Azure Storage? Well, each account that you set up using your Windows Live ID can have up to 100 terabytes of data. That's why we like to say that Azure Storage is very, very scalable. That's an enormous amount of data. And of course, if you need more than that, you can have more Azure Storage accounts. In other words, set up multiple Windows Live IDs with multiple Azure Storage accounts, giving you multiples of that terabyte data limit. Some individual pieces about storage and what we can store in there. Each queue message can be up to 8K in size. So fairly small messages, but obviously given the 100 terabyte limit, that's a lot of message you could store. Tables and the entities we put in tables are limited to 1 megabyte each, or about 200, I shouldn't say about, they are 255 field max. So that's per, if you want to think of it in row terms, that's per row. So in our customer case, each customer could be up to 1 megabyte. The entire table, or set of tables we have out there, can again be up to that 100 terabyte of data limit. Then block blobs can be 200 gigabytes in size, and something known as page blobs. There are two different types of blobs out there depending on how you want to store things in chunks. It can be 200 gigabytes for block blobs and 1 terabyte for per page blob. So again, these limits all then can allow for many, many, many blobs to meet that 100 terabytes of data. If you do want relational database in the cloud, that's when you need to start thinking about SQL Azure. SQL Azure is the relational database in our Windows Azure platform. It is based on SQL Server 2008 R2. Now when you say it's based on, what does that mean? Well, it's not a full-blown SQL Server instance. It's not SQL Server 2008 R2 in completeness. There are a number of limitations. The number of limitations is relatively long and probably a little bit too long to cover in this presentation. Plenty of places out there that you can reference some of those limitations. In fact, I'll be pointing you to some references here at the end of our talk, and one of the lists is for some of those limitations. But to give you an appreciation for the numbers of and types of limitations we might find for our SQL Azure database, here's a good quote from Azure in Action, which will give you some indication about what you're looking at with regard to SQL Azure. A lot of people have even said that SQL Azure is essentially SQL Express. Well, that's not exactly true, but you can start to appreciate why that comment has been made. And that is, if you look at the subset of functionality, if you can do it in SQL Express today, you can probably do it in SQL Azure. Anything beyond that, and it might be a bit questionable. There's a number of limitations there today with SQL Azure. And by the way, Microsoft hopes to increase the capabilities in many of these areas to include SQL Azure to one day be able to incorporate a fair number of, if not all, the capability you find in SQL Server today. A couple of ideas about giving you what some of the limitations are. For example, there is no replication in SQL Server, I should say SQL Azure, excuse me. So no replication, and also things like backup, which we'll talk about in a bit, is also something that you have to kind of do on your own with SQL Azure. There's no backup capability today. So how do you actually manage your SQL Azure database? Well, it's again through the developer portal that one sets up and creates their actual SQL Azure account, just like we set up hosted services, just like we also set up our Azure storage. Additionally, you'll find that using any SQL Server tool today that you feel comfortable with, whether that be Server Management Studio SSMS or SQL command line, even Visual Studio or SSIS, all tools that you're probably familiar with if you dealt with SQL Server today, all tools that you can also use in accessing and managing your SQL Azure databases. There's even a data migration wizard that can help you migrate your data in and out of the cloud. This migration wizard will take a look at your schema and your things like your stored procedures and what have you in SQL Server on-premise and tell you how to migrate that information and data into the actual SQL Azure cloud environment as well. From a code perspective, how do you access SQL Azure from our .NET code? Using the same kinds of capabilities, the same APIs that you're used to and accustomed to working with SQL Server inside your own data centers, namely things like ODBC and ADO.NET, to include extensions those like Link and Entity Framework and WCF data services. All of those same APIs work with SQL Azure just as you'd find they'd work with SQL Server. In fact, one of the ways to start to think about moving things into the cloud may not necessarily be from an app perspective. Many organizations are looking to move their data into the cloud before they start moving applications. Given the data migration wizard and given the similarities between SQL Azure and SQL Server, one might find that moving to the cloud from a data first perspective is actually a little bit easier. So from a developer's perspective, whether or not you have applications on-premise or off-premise, or it's in the cloud or in your own data centers, you'll use the same APIs, the same core set of mechanisms we use today to get information in and out of SQL Server. You'll use those to also access SQL Azure. Using tools like SSMS, SQL Command, Visual Studio, your favorite tools that you use today also are available to manipulate those databases in SQL Server. SQL Azure. What's the cost for SQL Azure? Well, $10 per gigabyte per month. Now, if you refer back a few slides to the cost of Azure Storage, one can start to appreciate why a lot of people are starting to see the differences and reasons to moving to Azure Storage. SQL Azure is much more expensive, at least on a per gigabyte basis, than Azure Storage. And in particular, the most direct correlation is to table storage, since it's also structured data. Now, having said that, obviously we're dealing with a relational database, a full relational database in SQL Azure versus table storage and its limitations in that we're really talking about that fancy spreadsheet. So there are some pluses and minuses to both sides, but certainly on the minus side, SQL Azure is much more expensive. Now, is that more expensive than your own data center? A lot of costs go into setting up data centers and managing SQL Server inside your data centers, so this might be a cheaper alternative compared to that. Again, additionally with SQL Azure cost just for the raw data storage, we also have to consider some other costs, and that is with SQL Azure we have to consider data in and data out transfer costs. So bandwidth again costs 10 cents per gigabyte in and 15 cents per gigabyte out. Again, the changes there for the Asian region are mentioned as well. Again, 30 cents and 45 cents due to the fact that it is costing more for Microsoft to operate data centers in the Asia Pacific region. One nice thing here is that you'll notice that there are no transactional costs for SQL Azure, whereas there is a penny per 10,000 transactions in Azure Storage. So that's one benefit in SQL Azure. If you're doing something that's heavily transactional based, you might find SQL Azure cheaper on that regard. One other big limitation with regard to SQL Azure is the database sizes today are relatively small. 1, 5, 10, 20, 30, 40, or 50 gigabyte limits. You set up your limit, in other words, the size of your SQL Azure database when you're establishing your account. You can increase, say for example, maybe you selected 10 initially. You can work with the management tools to change that to 20, but 50 gigabytes is the hard and fast limit today. Beyond 50 gigabytes, what do? Well, you're going to have to learn how to partition your database either vertically or horizontally to go beyond that 50 gigabyte limit, which often means also changing your application code to deal with those partition areas. So going beyond 50 gigabytes a day can be a bit of an issue in getting applications and data into the cloud. To wrap up, ladies and gentlemen, I'd like to leave you with a few lists of resources to point you in the direction of learning more about Windows Azure, to include things like our compute Azure Storage and SQL Azure technologies, which we talked about here today. There's of course the Windows Azure site Microsoft.com has set up to get started. If you want information on some of the tools we talked about here today in terms of getting things set up in your development environment for creating applications and getting data set up in the Azure environment, take a look at the link here on MSDN. If you're looking for what is a list of full-blown list of those limitations, SQL Azure versus SQL Server, you'll also find this MSDN page to be very useful. The developer portal, the portal to get things deployed to and set up in the cloud, is listed here, windows.azure.com. And of course, in the category of shameless commerce, I'm going to try and promote our Intertech class on Windows Azure, Complete Windows Azure, which starts this October 2010. So if you'd like, please see intertech.com to sign up for our class coming up, learn many more details on the Azure product and technology, get both our applications and data inside the cloud. So what have we learned today? Well, we learned a little bit about Windows Azure and why we might want to move to Windows Azure. We've also started to explore some of what you need to get up and running, getting applications and data moved into the cloud, in particular things like Visual Studio and the Windows Azure Sdk. We've looked at the Windows Azure architecture, how things are running inside of the cloud with regard to the Fabric and the Fabric controller, and how that's simulated with the Dev Fabric and Dev Storage. We also have taken a look at a little bit of code, things like what web and worker roles are about, and what some of the code in those might look like. And of course, we've looked at what are some of the data alternatives for housing data inside of the Windows Azure environment, to include Azure Storage and SQL Azure. And we've taken a look at some of the costs for each of those, and hopefully finding that the costs there are ones that can actually help us, not only in terms of getting applications up and running faster and more scalable, but cheaper than what we might find in our own data centers. Some additional resources can be found also on our Intertech site, not only with regard to Windows Azure, but also lots of other technologies which we work with, to include the Java and .NET communities. Training is always available, and we'd welcome you in any one of our classes. Please see our intertech.com site and sign up today to include again that Windows Azure class starting up in October. And we also have wonderful consultants that can help you, especially if you're exploring moving applications and/or data into the cloud. Please contact us. We'd love to try and work with your organization and help you at least assess the cloud technologies and find out if there isn't both a good rationale and a cheap means to get you into the Windows Azure cloud. Great people like Tim Starr, one of our MVPs, Microsoft MVP that works at Intertech, can help us getting an assessment of your technologies and your code and data as far as it might relate to the cloud, and take you down that path of getting that first application in the new Microsoft Windows Azure environment. I want to thank everybody for taking a listen to my talk here today. And if we can help, again, please let us know. You can reach me via email, jwhite@intertech.com, especially if there's something in the Windows Azure little Hello World application you'd like to see and have that code sent to you. Send me an email. I'll be happy to send it to you. And also find this complete talk in terms of the slides provided to you via our intertech.com blog site at intertech.com/blog. Look under the Azure link and you'll find more links to pick up this particular PowerPoint presentation. Thank you very much, and good luck with your Windows Azure exploration.